Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable Series. This particular Roundtable Series is all about the Daniel J. Epstein Department of Industrial and Systems Engineering, and I will be your host for today's event. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the USC Viterbi School of Engineering. I'm joined today by three fantastic guides to the department. You couldn't ask for a better group of faculty members to walk you through this program and to answer your questions and to learn a little bit more about the discipline and the major of industrial and systems engineering. I'm going to let each of them introduce themselves here in just a minute, but I'm going to start with our chair and faculty member, Dr. Majid Dasuki. Dr. Dasuki?
Yeah, thank you, Paul. I'm Majid Dasuki, professor and chair. I've been at USC since 1993, so I know every crack and cranny around this campus. So if you want to know where all the good spots to hang out, just ask me.
All right, now we're turning it into a hangout session. Awesome. Dr. Palmer.
Hi, I'm Kurt Palmer. I teach our courses in statistics and quality and simulation. And I'm also the associate chair of the department, which means that I work with Dr. Dasuki to try and help manage the undergraduate program, make sure that we have enough class sessions offered so that when you need a course, you get the course, and keep everybody on track towards graduating.
Fantastic, thank you. And last but certainly not least, Dr. Moore.
But possibly least. I'm Jim Moore. I'm split between industrial engineering, which is my primary department, civil engineering, and this Price School of Public Policy. I focus primarily on transportation systems. I've been here since 1988 and have loved every second of it.
All right. Thank you very much. As I said, what we're going to do today is we're going to talk about the Daniel J. Epstein Department of Industrial and Systems Engineering and allow all of you to learn a little bit more about that possibility as you think about applying to our programs. Here's how today's session is going to work. I'm going to lead the first half of the discussion with our faculty members, giving an overview of the program, answering the majority of what you're probably looking here to learn. And then towards the latter half of the session, then I'll open it up to you as our audience, where you can start asking questions of our faculty. I'm going to ask you right now to hold those questions, though. So please don't ask any questions during this first part of the session. I'll let you know when it's a good time to use the Q&A function, and I'll point you to that function then. So please, no questions right now, because we just can't answer them. We can't manage that process. The other thing I'll ask is that when we get to the Q&A section, I'll remind you at this time, toward the latter half as well, that we were not going to ask any admission or application related questions. We have specific admission information sessions that are run twice a week. Today's session is all about the department, all about the discipline, and let's make sure that we gain as much knowledge as we can from our faculty members. So here's our first question to whoever wants to start us off. Probably a seemingly simple question, but it's going to be complex in its answer. What the heck is industrial and systems engineering? Can you give us some guidance on what this program's all about? Sometimes students have sometimes not even heard of it before.
Kurt, why don't you go first? I don't mind going last on this one.
Okay. So the question you asked, Paul, is the $64,000 question in our discipline. It's something we've been, as a profession, struggling with. How do we communicate this? We know what we do. It's how do we tell the rest of the world what do we do? And it's, you know, pretty close to everything, but I'll try and narrow that down a bit. So industrial engineering is sort of right on the cusp between the business school and the engineering school. First thing you have to know about us is we are engineers. So we're very interested in how do things work. It's just that the kinds of things that we're interested in looking at are not just equipment or computer systems, but systems that involve people as well. So that's where we start to get into the management side of things. Industrial engineers work shoulder to shoulder with business managers on a regular basis. We understand and work with more frequently than most other engineering disciplines the idea that to get engineering projects done, you need resources. And one of those resources is money. So you have to go to the business manager and say, hey, I need this amount of cash so I can do this wonderful thing for you that will let the company do these things that we can't currently do. Now, to accomplish that, we study a lot of different areas and we practice in a lot of different areas too. I mentioned my background is in statistics. That's one area where we practice, but we also practice in optimization, which has to do with allocating scarce resources. We practice in scheduling and logistics. So how do you make sure that grandma's cookies get to grandma or get to college, to the dorm room, so that grandson and granddaughter can enjoy those wonderful cookies. We work in manufacturing. We try and figure out how do you build things like, I don't know, a Boeing 747, which is not a small thing to build. So how do you, pick out all the different parts of it and get them all, figured out and coming together in the right order and assembling it and making sure it works and all that good stuff. We work in human factors, which has a lot to do with safety. So how do you make sure that people don't hurt themselves at work? And how do you make sure that the public doesn't get hurt when they're using things that we design and operate, things like railroads? And Jim was mentioning transportation systems, but ground level railroad crossings can be a real hazardous thing. And we know that because we have a few of them right around campus. So we, some of our faculty members have taken a close look at some of those crossings and had some interesting things to suggest about how to make them safer. We work with information systems, databases, things like, if you buy something at Amazon, how do those recommendations come to you? When you say, I want to buy a pair of bunny slippers, how do they figure out which company's bunny slippers are going to show you and what alternatives that you might have to look at? Also, it's economics and organization, management science is another part of what we do. So that's sort of, giving you the broad spectrum. My colleagues also have their specializations as well, so that they can probably point you towards more specific things in their areas of specialization.
You didn't leave very much out. Very complete.
Well, I'm a generalist. I like to, give the broad overview and then let the rest of you fill in the details.
And now I'm only gonna ever think of is I want some cookies and some bunny slippers right now. That's all I'm thinking of.
So let me add some examples. I like to teach by example. I think it's really the best way of teaching. And right. So the biggest difference between us and other engineers is the scale of the problem. The scale of the problem we try to solve. Systems is our name. So when we think of systems, we're thinking of, reasonably big systems that have humans, technology, all types of stuff, hardware, software, and interactions between other businesses and interactions between government and a corporation, if you happen to be working at a corporation. But let me give you a concrete example, I think, that really illustrates the difference between us. And if I have time, I'll do a second one because I don't want to leave it in kind of the first example is kind of not a happy example, but it really illustrates it. So I was very involved, and I'm still very involved in interviewing scholarship students who are given a scholarship at our university. And one of the things we do at our scholarship interviews is we just put a kind of an open question background. This happened after 9/11. Some of you, this happened 20 years ago. So this is, a while ago, but the country was really traumatized at that time. And there was really this notion where what could engineers do to help address this problem. And during the scholarship interview, I happened to have an interview with a computer scientist, electrical engineer, and an industrial engineer. I asked them all this question. I asked them, what would you suggest to the airport? What could you do to help them prevent the next major terrorist attack as an engineer, as an engineer? So the computer scientist, of course, answered the question this way. I will help them identify some software which could help determine which individuals are more likely to commit an act of terrorism. Okay, that's basically what a software engineer would say, and a computer scientist. So I said, well, this person would make a great computer scientist. And then came, and I don't recall if it was an electrical engineer, but a mechanical engineer, but both very similar. They said, well, I would develop finer and better sensors where they could detect some potential threat, the sensors you walk through the airport. I said, well, this person would make a fine electrical engineer. I think the last was an undeclared engineer. And the undeclared engineer answered it this way. And then I said, boy, this person would make an excellent industrial engineer. They answered, I'd look at the system and I'd see where the cues are at. Because where the cues are at are probably going to be the target places for a potential terrorist attack. And I would look at ways to reduce the queue, to minimize the impact of the terrorist event. And I thought, my gosh, I recommended this student, industrial and systems engineering, because that is exactly what an industrial and systems engineer would do if they were charged that time. Queues are at the heart of what we do. We try to minimize them because they present all sorts of problems. In this case, queues presented a problem because that's where most likely a targeted person would do it. So that's kind of like a happy example. But if you think about it in terms of what you do in your everyday life, we all have iPhones, right? We all have iPhones. And industrial engineers are going to be a big part of getting that iPhone from the manufacturer to you. And it's not that simple. If you think about your iPhone, think about all the components that go into it. You have the screen, you have the memory device, you have probably a soundboard in there, you have the chip in there, you have all these. They're not all by Apple. Probably all these components are made by different vendors that they get. So you got to get this components to the assembly plant, and from the assembly plant to you. So think about all the steps that go in place. The transportation system goes from the assembly plant to there, to the manufacturer. And that's probably in China somewhere or somewhere in Asia. Then it goes from the assembly plant, maybe by train or truck, to a port. And it gets on a ship, goes clear across the United States. Then it gets probably assembled somewhere, put it in a warehouse, and then put it into another warehouse. And then eventually it makes its way to your phone. The amazing part is we can track it and tell you as a consumer where exactly your phone is at and when it's going to be delivered and on time. That takes a lot of smart optimization software and models and technology. And at the heart of what we do is we make that happen. And that's what industrial engineers do. Okay, I can say it any differently.
Efficiency, optimization, making businesses run better. ISE does it all, and they're at the intersection of all of these types of problems. So thank you very much for that. Let's talk a little bit about the curriculum, if you wouldn't mind. Maybe Dr. Palmer, you could take a first stab at this because I know that you're heavily involved in that. What would be the types of that arc that students would take in the undergraduate curriculum for industrial and systems engineering? What types of courses are they taking? What are they learning?
Yeah, sure, Paul. I'm happy to try and explain that. So like every other student at USC, you begin your degree with general education. Now, I don't mean that your first course and your first several courses are all general education, but that's a primary component of the degree program. And general education is where we train you how to recognize what's going on around you as you're doing your engineering, how to be sensitive to the fact that different communities have different priorities, and you have to serve those as an engineer. You have to be aware of how to think about things quantitatively, but also how to look at the society in which you do your engineering. And it helps if you're able to communicate. So being able to write and speak are important skills, especially for industrial engineers, because we're, that right hand of the business manager, and we're often trying to gather information from the rest of the community, the rest of the business. So we do a lot of talking to people. Some people say ISE stands for I'm a social engineer, because we like talking to people. So that's the general education component. And every student at USC follows the same general education requirements. The next thing is you need to get your basic math and sciences. So because industrial and every form of engineering is exploiting basic science, applying that to engineering problems. So you need to understand the science and the math. So you're going to take some chemistry, some physics, some biology, not all at once, not all at the beginning of the program. You spread it out over the 4 years. Some of it we have to sequence so that you're ready to take your engineering courses, have the necessary background. So you can do your calculus first, get your linear algebra out of the way. And then you get into your engineering discipline. So we have a set of courses that we refer to as the core of industrial and systems engineering. And this is where we're building up fundamental skills and also giving you an introduction to all of those areas of practice that I was speaking about earlier. So you're going to take some probability statistics, you're going to take some operations research, you're going to get some human factors, some database design, some organization management kinds of stuff, some engineering economy, how do we estimate the cost of a project, and how do we look at the alternative investments of, should I put the money in the bank? Should I put the money into building a new facility for my manufacturing or my service operation? Should I buy some new vehicles to help move the cookies around? Then we get into our areas of emphasis, or we call them focus groups. So we have 2 elective focus groups attached to our degree currently. One of those is in what we refer to as operations, and the other is in the area of information systems engineering. So in operations, we're focused on how do businesses get things done? How do they produce products? How do they provide services? You have to come up with a plan and a schedule for how do you get all the materials and services you need from your suppliers? And how do you allocate the equipment and the people within your own organization to producing those products and services for your customers? And then how do you distribute those things to your customers? So you also have to look at facilities layout and supply chain management. And there's also, quality assurance. How do you make sure that the product or service you're delivering to your customers is actually what they want, right? And you're able to do that consistently, satisfying the customer's needs. Right, so those are the main courses in that focus group. But we also have a list, a pick list, we call it, where you can select additional courses as part of the focus group. So you could look at things like Six Sigma, or which is a quality assurance problem solving technology, or you could look at accounting, or you could look at systems engineering. How do you manage, building a really huge system like an aircraft carrier or a satellite communications network? There's a lot of very well-developed systematic approaches towards making sure that all the disciplines that have to be involved in doing those really huge projects coordinate with each other properly and make sure that we get the thing that's needed. On the information side, there are some courses there that we emphasize. One of them has to do with enterprise resource planning. That is basically, how do managers keep track of all the information you need to run a business? You need to know about your customers, you need to know about your suppliers, you need to know about your physical facilities, you need to know about your employees, right? And so usually a lot of companies have separate information systems that are keeping track of each of those pieces. And somehow you have to pull that all together. And that's what the enterprise resource planning system would do, is help you to forecast how many cookies are going to be needed to be sold next year, and make you aware of how much flour and butter and sugar you have to order from your suppliers, and then work with the trucking companies to get that delivered to your facility, and then make sure you have enough ovens ready to go so that you can bake all the cookies, and you have the right number of people in place that are going to mix the stuff and get it into the ovens, and then get it packed up and on the next set of trucks that are going to send it out to the individual customers or stores that are going to sell it for you. Right. So that's, all the stuff that we're trying to keep track of, the necessary information to help managers coordinate that system. Right. So that's what enterprise resource planning is about. And everybody that's doing information systems focus would take an enterprise resource planning course. But then you have a wide variety of places you can go from there. These days, data analytics is an area that's very big in all disciplines of engineering. But since we're trying to help the managers gather the information about how do you run the organization, it's a natural subject for us to study. So how do you take huge databases and tease out of that the key bits of information that are going to help you run the company better tomorrow than you do today? That's one area you could look into. Also, how do you go about setting up, gathering the information and pulling the information back out when you need it, right? So we could talk about creating web pages or websites that help get the information into a database or pull the information back out of the database when you need it. That'll help present that information to you in a way that's going to be really easy to understand what's there and what the story is that it's trying to tell. I'm trying to remember some of the other electives in our pick list in the information systems course, but go ahead, you seem like you have a question.
I was going to say, I think it might be also helpful to hear about another specific course. I know, Jim, you've taught another course that I think provides some good examples of like the capstone learning that would happen in industrial and systems engineering.
Very important course. Good question.
We've got an unusual capstone course. So all of our undergraduate programs school-wide are accredited, and they all have a capstone experience. I like our capstone course best because, frankly, it is the best. But the others are very good too. Ours, though, is a year long. It's not a one semester experience. It's organized around real world problems. There are industry clients involved. They're not paying the university or the students for the work that they're doing, but the problems are real. We typically go to these companies and say, we're interested in a problem that is important to you, that would really add value if it were solved to your bottom line and the quality of your operation. But it shouldn't be urgent, because our experience has been, while our students are very capable, the first time you're really gearing up to go through a team-based real world experience where you define the problem and then you solve the problem and you bring to bear the various tools that you have acquired, there's a lot of decision making that has to go on for the first time. And students do an excellent job in this context, but they tend to need a little more time than an experienced professional. So we ask companies to give us problems where we can take the time necessary to make sure the students learn as much as possible and take the time necessary to actually offer a quality solution to the problem the company faces. I don't really think there's another class in it like it in the program anywhere. And, we're very proud of it. It's hard to coordinate. It's kind of labor intensive for the faculty that are involved, and it's absolutely worth it. It's a very rewarding experience. We meet, a team of faculty meets individually with every student team every week. So there's some fixed schedules on the front end of the process, and there's some milestones that you have to meet. And we try to stay in touch with the students and make sure we understand their progress and answer their questions and make sure those milestones are in fact met, so that ultimately the experience concludes with results. And generally those results are a success. They are not inevitably a success because it's all real, right? And not every project succeeds the way you want it to when it begins. It's always a success in terms of student learning, and it's usually a success in terms of outcomes for the client. But sometimes you're trying to knock down problems that no one really understands well, and the team simply might not make the progress that they hope and intend to make on the front end.
It's a very cool class where these students are acting as almost real life technical consultants for companies. Do you have off the top of your head an example of a particular, if you're able to talk about it, a company in the past that has done this and a problem that one of the groups of students had to solve, just to bring it into a little more of a reality?
So we try to have a mix of different kinds of clients. We've had a number of projects with the Aerospace Corporation. There's a project that's gone on for a couple of years at this point that really is generating a satellite tracking system. So the antennas you need to move to track satellites are hard to move. They wear out, they consume a lot of energy. So you really need to very carefully plan out how you are going to move those antennas so that you can track the satellites you need to track and be in communication with them. And that's got a combination of different elements to it that's turned out to be very complicated. And so it's had to go on for more than a year. That creates a circumstance where a project gets picked up by one team, worked on and set down and picked up by another. And that's a very real world sort of work experience also. We've had a team that did some work with SGL Carbon, which is a company that manufactures brake shoes. And they were losing a lot of product. They simply did not know where it was in their treatment process. And they needed a new process, basically. And frankly, I think the team did an excellent job and came up with a way for them to keep track of their work in process inventory that they should have had from the beginning, right? But they didn't, and it was costing them money, and now it's not costing them money. And we're all feeling very virtuous about what we were able to do for them. We do a lot of work in healthcare contexts. Pre-pandemic, access to healthcare contexts have been a bit more restrictive of late, but healthcare is a process. There are a lot of queues involved. There's a lot of waiting involved. Queue management of the sort that Professor Dasuki mentioned is a big part of managing the quality of healthcare. And frankly, there's lots of room for improvement in that context. Turns out nurses are a wonderful population to work with. They're very patient-centric. Physicians tend to be very physician-centric. So it's, if you're trying to affect process improvement in that environment, nurses really are the go-to group because they feel ownership in terms of the quality of the outcomes. And they're sophisticated, talented, and they make great industrial engineers. So there's actually a well-defined industry or interface in the discipline between nursing and industrial engineering. And the list goes on, right? Any sector you can imagine has got the potential to generate a problem for our students to work on.
Thank you for that. I think it's a great combo to understand kind of the arc, kind of the involvement of theory and direct hands-on work that a student will do in their undergraduate education. I want to switch gears now a little bit. Maybe Dr. Dasuki, you can kick this one off about research. What type of research is going on in the department? And maybe after that, you all can jump in with your areas of research and what's exciting about research. And I'm rambling, but I think you get the question.
I got it. It's a good segue. Actually, we have a pretty involved undergrads involved. We believe undergraduates can do research at USC and in our department. In fact, in the last, I would say, last 2 academic years, we've had heavy involvement with undergrads in research. We have actually specific programs that we've been able to get fundraise and support that. Actually, this summer we had 9 different student teams working with faculty advisors working on a summer project and doing research. This fall we have 5 other teams doing it. All nice parties, you get great experience, and you get paid to do it. So it's a win-win for both ends. And these are not made up projects; they're real projects. The department has quite a few research centers. We have a research center that we're involved in, transportation. I'll talk a little bit about that in a minute, because that's the area I work in: production, inventory, and logistics and transportation. And we also have, as I mentioned, after 9/11, the federal government created research centers for security, and we have the first center that creates, which is heavily involves also undergrad students in their research. We also have faculty involved in the manufacturing lab, the 3D printing, which is really you think about the exciting research areas out there. One everybody hears about is AI. That's very popular, and our department is very heavily in that area. But we do more. So the most common research question that's in AI that you learn about is machine learning, and most of that is really prediction. Can we predict what you're going to do next? That's what Facebook, Google, or any of these sites are trying to predict what you're going to do so they can provide the services that you need. But we, in the added dimension that we bring into these type of research questions, we're also thinking about prescriptive analytics, which basically says, okay, now we can predict what you're going to do. Can we use that information to optimize how a system should behave? So a lot of our research questions are focused on not just prediction, but also prescriptive, which is basically, can we design and optimize the system? So let me give you an example of one of my own particular research projects, and which is something I'm sure you're all familiar with. I'm sure you all use Uber, Lyft, and those services. So one of the things that transportation engineers and researchers are really interested in is congestion. What's the impact of these services on congestion? And so we have models that can predict the behavior of passengers and using these services and its impact of congestion. So if you go back, and one of the reasons these services became very popular is they can convince the cities. They convinced the cities that we're going to solve your congestion problems. You'll bring us into your services and we will solve your congestion problems. And so all the cities went for it because there was some political pressure against it because the taxis they saw it as pure competition and it would hurt. So initially they came in and they thought, okay, we're going to reduce congestion using these services. About 15 years later now, we're at a point to study that and see if congestion has gone down. So empirically, we have empirical data, meaning when people talk about empirical research, that means they're basing the results based on data collected outside the real world and doing some analysis. So empirically, actually, we've seen congestion has gone up by 10%. Now, the question is, how much of this is directly impacted by the increase in these services or other factors are causing this increased congestion? So it turns out, using some optimization models, you can show that Uber and Lyft have actually, the way they do their business actually adds to congestion. And it wasn't obvious, and if you think about it, it's intuitive. If you thought about it, if you understood the way transportation systems behave. Think about it. If you're driving your own car from A to B, you're driving a distance of X, okay? Now let's say you call up Uber and say, I need to go from A to B. Well, that car is not right at A. That car is somewhere else. Let's say it's at some point C. So now that trip is an X plus Y distance. So you have this extra distance that the driver has to go to pick up the passenger. Plus you have this issues with double parking. The interesting thing about that is we've had students developing models who could predict exactly how much congestion will go up if you give me basically the travel pattern where the people are going to and where they're starting, where they're ending. We have models which can predict how much congestion will go up, and sometimes it may go down. If you can convince people to share the same car, then obviously you can start reducing congestion. So these are the kind of research questions we kind of work on. And as you notice here, they're at a much higher level than other engineers. We're looking at systems and how they will behave, and we try to optimize.
That's perfect. Thank you very much. Others want to jump in on your research examples, a quick overview of what you're doing, or?
I find it easy to work with students with undergraduates in particular, because the school makes it easy, right? So typically faculty do research with graduate students. That's the standard model. The faculty write research proposals that brings funds to the institution. The proposals include budgets that pay for graduate students. So it really has not been a simple matter to write research proposals that fund undergrads, and the school has stepped into that breach. They understand that we're at a research university, students want a research element to their work here. And so the dean's office manages the budget of the school, and he sets aside resources to pay students to team up with faculty on questions that are of interest to both parties. And typically these are projects that are related to the kind of funded research that Professor Dasuki was talking about. I tend to use students in a specific way. There's a specific category of research that I need done. It's got a skill set they frequently have. And I aim at trying to produce unrefereed publications. So the goal is to be able to describe a problem and a potential solution well enough that we can get it into a newspaper someplace. And who knows, maybe inform public debate.
So I checked really quickly to some of the projects we funded last summer with undergraduates, and this is actually one that I find, they're very broad. One of the projects is titled Applying Dynamic Programming to Optimally Play the Trombone. So believe it or not, the techniques we teach you can make you a better musician. How much better, I can't attest to.
Do we know the project was a success?
I haven't heard the person play it before or after, so I cannot speak to that.
All right.
Well, I think you just created the subtitle of the new brochure. So I think that's exactly what we're going to put out there now. So
There you go.
that's the new subtitle to ISC.
Very good.
All right. One last question, and then for all of our audience, start getting your questions ready. And I'm going to ask you to start doing this now. You can click on the Q&A feature at the bottom of your screen and start typing in questions. And the way we're going to answer the questions is by all of you upvoting. So you'll see the little thumbs up, and it'll be democratic. Whoever gets the most upvoted questions at the top, that's where we're going to go down that question list. We're answer as many as we possibly can in the time that we have left until 5 o'clock, where we'll have to cut this off. But as a reminder, please no questions about admission or the application process. I would encourage you to sign up for one of our information sessions. Michael will put a link into our chat so that you can make sure and know how to register for one of those. And that's where we'll get into detail about that process and also make sure that we address all of your questions in that session. So for my faculty, the last question I have, and then we'll hand it off to the audience, is outcomes. Undergraduates go through your program and they leave and they go do something else. What is that something else? Where do they go? What do they do in that something else?
Okay, so I actually do a survey with our graduating seniors each spring to find out where they headed next. What are they up to? And a lot of our graduates go into, let me preface this by saying the first and most honest answer is, as Professor Dasuki suggested earlier, everywhere. Industrial engineers can contribute to the economy in every sector of industry you can think of. Now, when I talk about where are the organizations where we have placed the most students, say over the last 6 years, the management consulting firms are right at the top of the list. Companies like Ernst & Young, Price Waterhouse, KPMG, Accenture, Deloitte, right? And these are all companies that sell consulting services to businesses, where a business manager says, I need somebody who can help me figure out how to move stuff around, or how to create an information system, or how to make my operations safer, or how to make sure that my customers are getting what they want. And I don't have the expertise within my own company to do that particular project. So I'm going to hire one of these consulting firms who have the experts that can help me do the job. And that's where a number of our students have gone. But when I say a number, it's still, maybe on the order of 10 to 15% of our graduating class go into that. And that's the biggest hiring area. Some of the other places that people go, like Microsoft, to help manage the logistics of making Xboxes and tablet PCs. Northrop Grumman to help manage making fighter jets. Pepsi to help manage making wonderful, delicious beverages. Let's see, some of the other places, I've got a list of about, 60 or 70 companies that have each hired one of our graduates in the last 6 years. And just glancing down through the list, Disney, how do you run the theme parks? Uber, how do you get all those vehicles around to pick people up? Let's see, we've got some construction companies, we've got NBC Universal, we've got United Healthcare Group on the healthcare side, we've got Bank of America, Merrill Lynch in the financial services sector, Facebook, we've actually placed somebody with Facebook. Land O'Lakes, do you like butter? We have people that make butter. Or ice cream. SpaceX, we have people that make rockets.
It is quite literally everywhere. It is quite literally everywhere, because ISC is going to be involved in all of these different topics. It reminds me of a recent podcast episode we just did for all of you. And Michael, I'm going to ask you to see if you can find the link to the blog post on Kristen Sayuni's episode. And the blast for your past, Dr. Dasuki, one of your ex-students, Kristen Sayuni, we just did a full 2-part episode with Kristen Sayuni, which actually gives you a real life example of everything these guys are talking about. And it's interesting, I was listening to you, Magic, talk about kind of the process. And it's so funny because it's like hearing her explain her whole process as she worked through UPS, as she worked through Disney, and now as she's working at Apple, doing all of these processes. Almost all of your examples were like all of Kristen Sayuni's career path that went through all these different areas.
She's done
and
it
so
all.
I encourage you to take a listen to that, because that's one woman's example of how she went through that process, and putting some real life tenor to it.
I think she was handling the whole part of the entire supply chain for Apple.
Yeah, she was. And she was probably telling us more than she should have on the podcast. So, all right. So for all of you out there, your chance to ask questions. I haven't seen any questions pop up in our Q&A. Oh my gosh, there they go. Oh, they just started popping. It's like I said something and it's ready to go. And again, upvote them as much as you want. But let's see who gets in here. We only got 3, so this will be ready to go. Thank you, Michael, for putting the link to the podcast there. You can listen on Spotify or wherever you find your podcast. Let's do this question. Estella asked this question. What sets USC industrial engineering apart from programs at other universities, or what makes your program special? What makes you all the best?
I'll be more than happy to answer that. I think we have a very active research program for undergrads. I think, and we also fund you while doing that. So it's not just, so it helps pay the bills, but more importantly, it gives you great experience. I think our undergraduate experience is great. I think another big factor is, as Professor Palmer mentioned, and is our students get jobs and they get it easily. And that's because we have a very strong alumni network. So I think from the experience that you get in here, with, of course, courses are taught by wonderful faculty, but importantly is that you get, hands-on experience with your research, and just as important, there's a network of graduates who are going to help you, and they're going to help you, find a job. They'll help mentor you, and they care about the department. They care about the department, and they make sure that the students that are in the department are successful during their studies and when they graduate.
I'd like to hear from others as well. Dr. Moore?
Well, shirt sleeves in January has a lot to recommend it. There is some locational advantage. That network that Majid refers to is colloquially known as the Trojan family, and it's not just marketing. It's quite real. I mean, LA has been here, USC has been in LA since we were in practically a pueblo. So we've got a lot of graduates burrowed into the local economy. And the fact that you're applying to an operation that employs USC personnel doesn't mean, or USC graduates as personnel doesn't mean you'll get the job, but it may get you the interview. So there really is, I think, a competitive economic advantage if you're interested in working in California in general, and in Southern California in particular, if you've graduated from this institution. And intellectually, USC is a unique place. I mean, we've got 20, round up or down, 20 or so different professional schools, and interdisciplinary education is really very highly valued by the central administration, and the schools collaborate to try to provide interdisciplinary options. So you get a really unique quality education from that dimension. It's easy to fall into disciplinary traps. And this is an organization that deliberately maintains interdisciplinary links. And that really does change the timbre of your experience here.
Fantastic.
I'd say one of the things that helps set USC apart, and industrial engineering here especially, is the classroom experience. We have relatively small classes, and I say this as someone who did my earlier education at some fairly well-known and large state universities. So we have class sizes on the order of 30 to 40 for most of our classes. And that means that faculty members are going to get to know you by name. And it's not unusual for me to have students knocking on my door weekly, coming to office hours to talk with me about coursework, certainly, but about job possibilities, about graduate school, about whatever's going on in their life. So, if you want a place where you're not going to be a number, where you're going to be someone who is known by name, that's one of our advantages. The other advantage, as Dr. Moore was suggesting, is that USC is an actual university. And that means we're not just an engineering school. We have lots of different areas where people can take courses. And we have a great cinematography school. So if you want to take a night class where you're viewing movies that were made in the last 6 months and talking to the director and the writers, that can happen. And we have lots of students in our own program that take advantage of these opportunities just as one-off classes or as minors. We have a student who took a minor in theater, and her first job out of graduating our program was to join the road company of Cats. And she's made a first part of her career being a performer. And she's now,
Oh, Catherine.
yeah, and now
Yeah.
she's stepping up to work behind the scenes, to become a director and a producer herself. And that's where she's making use of her industrial engineering skills.
Actually, she's taking it a step further. She's actually also starting her own company, helping performers when they're on their downtime to do side jobs in technology.
Oh, really? That's
Yep.
super cool. That's super cool. Not to go back to talk about the podcast again, but in Kristen Sayuni's episode, just to put some, again, reality to what we're talking about here, you should go listen to it, Majid, because she talks a lot about you a lot. And essentially how you put her on this path, and especially to go to graduate school and to encourage her to apply for.
Thank me or curse me.
She thanks you, and so you're brought up a lot, and as another example of faculty caring, faculty being involved, faculty being in your life, whether you want them to be or not. That's going to be part of this process and part of the benefits of the private school education. Let's move on to Spencer's question here. Spencer asks, what's the most interesting ISC student project that you've been a part of? And the first thing that pops into y'all heads.
Wow. Okay. There's a student self-selected for this experience. He put together a team and applied to Mercedes-Benz for a combination of resources, part internship, part grant experience, but he was trying to develop a traffic information system that would diminish congestion. His goal was to make people compete more effectively for scarce road space and thus make their behavior more predictable. And he pushed himself beyond the boundaries of the conventional undergraduate program. He had to acquire software skills that we don't normally train undergraduates into, very specialized software. And he was a self-starter, and he asked for assistance and guidance, and he got it, and he was successful lining up these resources and brought himself some unique opportunities. And it was just an example of, in my mind, of somebody who took the toolkit we gave him, and then he really leveraged it and ran with it. And it just happened to be an application area that I particularly liked, so I paid close attention to it.
Very cool.
I could
Yeah,
throw another one but this is actually why it's just, you have to think like it's everywhere. You could do the skill set we do everywhere. And so, we have an institute also which funds projects. And so there was a very active, I'm not sure if the chapter is active as much as it is, but there was, everybody's heard of Doctors Without Borders, but USC also has a chapter of Engineers Without Borders. I'm not sure if it's as active as it used to be. This student came to me and said, wanted to travel to El Salvador. Like, why do you want to travel to El Salvador? Well, there's a village there that doesn't have plumbing and needs to get water from the river to the village. And it tends to be quite a long distance. So they have to walk and bring the well water in. And so he wanted to go there and help design a way to transport the water easier from the village to the city. So he set up the entire, logistics systems on how to design this water effectively from the river to some source and to the city where they could provide, where they can go at a much closer. It wasn't a plumbing system he was developing. It was basically a way to get the storage of the water from the river to somewhere closer so that you wouldn't have to constantly walk from the village to the water. And he set up the logistics systems to do this. The key thing in this research project, that's what that really interested me, is this isn't something he was taught. He wasn't taught the skill set to make water efficiently transport from the river to the city, but he understood the tools he learned. He could apply them in many different areas, and that's why this project interests me the most. It wasn't that it was the most technically challenging; is that he applied it in an area I never thought of applying it to. Right, and that's what's the creativity and the ingenuity part that you bring into the table, is that you have your own interests. Don't let the faculty come up with the application. Let yourself drive you. What's the interesting problems you're interested to do? Because believe it me, the skill set we teach you, you'll be able to do it.
That's fantastic. Let's move on to a quick question. They're all tied, so you all stopped upvoting. So I'm going to just pick one item real quick. Do most students intern? Timon asked this. Do most students intern during their four years of undergraduate? Yes, they intern in all the same companies we talked about with outcomes. Those same companies are here recruiting for internships, and then you're interning throughout your undergraduate years, and then that leads to those possibilities afterwards. Not necessarily with the same company, but sometimes that leads to the opportunities of gaining that experience that then it gets applied to another area. So internships are very regular and happen throughout your 4 years, and as early as the first summer after your first year there. The next question, if Garin, I think is his name, or Garan, if there's a research project I'd like to explore at USC that incorporates multiple fields of engineering, would I be able to work with other undergraduates from other departments within USC, or are research projects geared towards ISC with only ISC students? In other words, do I live in an academic silo of ISC? And I know Dr. Moore was talking about this a little bit with interdisciplinary efforts, but can we shed a little light on this?
I'll give you full disclosure. We're more siloed than we want to be, but every institution is. We're less siloed than most. I have attempted from time to time to set up our capstone course so that we could involve other units. And in part because our capstone course runs a year, that's inconvenient for other engineering units. I've tried to line up an opportunity for business students, but that would have to define a way for them to use the units. And that means going to the department, the business departments involved, and saying, and saying, all right, what would these units count for if students are going to take time out of their day and money out of their wallets and pay for them and take them? And logistically, it's been difficult to do. In a graduate work environment, a conventional graduate research experience, you might well find people from multiple disciplines because there'd be multiple investigators involved in multiple departments because people collaborate on research. The undergraduate experience in terms of research, we've tried to broaden. I'm not yet satisfied with where we are, but I take some consolation in the fact that we're still doing better than most. So I'm trying to be as honest as possible.
Right.
So one thing that occurs to me,
that's fairly accurate, but I'll add two caveats to this. Okay, there's really two big caveats. There are different types of research projects. If you happen to work on a research project in a center, most centers have multiple disciplines involved. So naturally, you'll work on a project that may involve some other engineer in a different area. So if you like, let's say you work in the Create Center, and they're going to have people involved in that center to double E, some are going to be industrial engineers, some maybe mechanical engineers. So if you work at a center, that's going to happen more. So that's going to happen more, I would say, homegrown, and it's going to be natural. Now, the other type, which not most of our research projects are going to be involved in the center. They're going to be involved with just your relationship with a faculty member. Now, Professor Moore is absolutely correct. Those tend to be much more siloed. But here's the answer I give the student that wants to do that. So the system is not set up in this individual silos where you can work with others. But if a student comes to me and says, I'd like to work with another student in another discipline and together solve this problem, I'm going to say always yes. Yeah, I'm going to always say yes. So although there's not in the individual case a system that's in place for that to happen, I know of no faculty member who, well, that's not true, but I know few faculty members who would say no. My answer is always, let's do it. Let's give it a shot and see it happen. So the long answer is it's doable, but a lot of effort, like everything in life, You have to show the initiative and take the lead, and we'll help you get through it.
Yeah, I was going to say that part of the difficulties that Professor Moore was describing are related to trying to do this activity within the curriculum, trying to get course credits for it. But there are other ways of doing things. There are extracurricular activities. There are a variety of clubs within the School of Engineering where students from many disciplines are members of the same club working on a specific activity collectively, jointly. There's also the possibility of starting something on your own. We have a makerspace at Viterbi, and there's nothing to stop you and a group of your friends from whatever backgrounds they might have from going to the makerspace and starting up a project. You're going to have to take the time to learn how to use the equipment safely, but we want you to get in there and tinker, try things out, have some fun. And yeah, you're going to learn along the way, and you're going to develop some great relationships, and so you don't get course credit for it. But there's a lot of things in life that don't come with course credit and are well worth doing.
Right. I think I might also add on to there too. A lot of this, a lot of the question got caught up in the term research, and sometimes students use the idea of research project, and that has a different definition for faculty, and the idea of actually creating a full research project or being part of something with a principal investigator. And a lot of times students are just looking to maybe engage in some sort of project that they're working on. Student organizations, design teams, clubs and organizations like Dr. Palmer was talking about. That's where you end up doing a lot of stuff in addition to class projects, because a lot of your curriculum is hands-on in its approach. It's not necessarily dictated by a recipe. And I can extend on that a little bit further in that you have opportunities to take technical electives that maybe aren't necessarily from your department. And so you aren't necessarily siloed specifically into ISE classes all the time with only ISE students, although that's fine. You'll have the opportunity to be engaging across the university. And that even goes back to general education that Dr. Palmer was talking about earlier. So recognize that these interdisciplinary opportunities, these co-disciplinary opportunities, these co-curricular programs, that's going to be part of your experience, and it's going to be engaging, and it's going to be fulfilling as far as whatever you're going to be doing moving forward. On that note, I want to take the opportunity to thank you all for joining us today, and more specifically add my special thanks to our faculty members, Dr. Moore, Dr. Palmer, Dr. Dasuki. I really appreciate you taking time speaking to our prospective students here. For all of you out there, last thing you got to do, or not the last thing, the first thing you should do if you haven't done so already, is start to work on your application. And the Common App is open now. It's due by December 1st. If you'd like to be considered for merit-based scholarships, get that application in. Go to commonapp.org or admission.usc.edu/Common App. Make sure that you list USC as one of the schools you're applying to. Make sure when you go into the USC supplement that you list one of the Viterbi School of Engineering majors as your first choice major. If you have any questions about that, join one of our our admission info sessions, or email us whenever you'd like to. Call us whenever you'd like to. We're happy to be here. But again, thank you all so much for taking time to visit with us. Faculty, thank you again. Have a great evening. We appreciate it.
Have a nice day, everybody.
Nice to see
Bye-bye.
you all.